Grade 9, Work and Energy, Part 2, Questions and Answers. Question number 1. Define life processes. Answer. Living beings have to perform various basic activities to survive. Such activities are called life processes. Question number 2. From where do we get energy for life processes? Answer. The energy required for various life processes is from the food that we eat. Question number 3. Why do living beings and machines need energy? Answer. Living beings and machines need energy for doing work. Question number 4. Give 2 examples when the object is not displaced in spite of force acting on it. Answer. A man is pushing a huge rock. 2. A man is carrying a heavy load on his head and standing still. Question number 5. State 2 necessary conditions for work to be done. Answer. 2 necessary conditions for work to be done are: 1. A force should act on an object. 2. The object must be displaced. Question number 6. Give 2 examples from everyday life where work is done. Answer. 1. We apply a force to lift a book at a height and the book rises. 2. When a bullock pulls a cart, it moves as work is done by the bullock on the cart. Question number 7. A man is holding a suitcase in his hand at rest. What is the work done by him? Answer. A man holding a suitcase at rest is not doing any work because work done equals force and displacement. So here force acts perpendicular and no displacement. Question number 8. Define work. What is its unit? Answer. Work is defined as a force acting upon an object to cause a displacement. It is equal to the product of force and displacement in the direction of force. W equals F into S. The unit of work is Newton meter Nm or Joule J. Question number 9. What are the factors on which the work done depends? Answer. The work done on a body depends upon: 1. Magnitude of the force F. 2. The displacement through which the body moves, S. Question number 10. What would be the work done when: 1. Force on the object is 0. 2. Displacement of the object is 0. Answer. 1. Work done equals force and displacement. If force on the object is 0, then work done is also 0. 2. If displacement of the object is 0, work done is also 0. Question number 11. What is the work done when you apply a 12 Newton force on a wall? Answer. 0. 0 work because there is no displacement of the wall. Question number 12. A pair of bullocks exerts a force of 100 Newton on a plough. the field being plowed is 20 meter long. How much work is done in plowing the length of the field? Answer: force equals 100 Newton, displacement equals 20 meter, work done equals force into displacement equals 100 into 20 equals 2000 joule. Question number 13. Why do we say work done against gravity is negative? Answer: it is because force and displacement are in opposite directions to each other. Question number 14. What do you mean by positive and negative work done? Give one example of each case. Answer: the work done on an object is said to be positive work when the force F and displacement S are in the same direction. Example: a baby pulling a toy car parallel to the ground. The baby has exerted a force in the direction of displacement of the car. Here, the work done will be equal to the product of the force and displacement, so work done is positive. The work done is said to be negative work when the force F and displacement S are in opposite direction. Example: when an object is thrown upward direction, its displacement would be in upwards direction, but the force due to Earth's gravity is in the downward direction. Question number 15. Suppose a force F is acting opposite to the direction of the displacement S. What will be the angle between two directions and what will be the work done? Answer: the angle between the two directions is 180 degree. In this case, the work done by the force F in the direction of displacement S is taken as negative and denoted by the minus sign. Hence, the work done by the force is F into minus S or minus F into S. Question number 16. A boy lifts a suitcase of 20 kg from the ground to a height of 1.2 meter. Calculate the work done by him on the suitcase. Assume G equals 10 meter per second squared. Answer: mass M equals 20 kg, displacement S equals 1.2 meter, G equals 10 meter per second squared. Therefore, work done W equals mgs equals 20 into 10 into 1.2 equals 240 joule. Question number 17. Which is the biggest natural source of energy? Answer: the sun is the biggest natural source of energy. Question number 18. Define energy. Answer: energy is the ability of an object to do work. It is also defined as the capacity to do work. Question number 19. What is the unit of energy? Answer: the unit of energy is joule, J. Question number 20. How many joules are there in 1 kilojoule? Answer: 1 kilojoule Kj equals 1000 joule, J. Question number 21. An object having a capability to do work is said to possess energy. Give 2 examples to justify this statement. Answer. Example 1. When a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. 2. When a raised hammer falls on a nail placed on a piece of wood, it drives the nail into wood. Question number 22. Name various forms of energy. Answer. The various forms of energy are potential energy, kinetic energy, heat energy, chemical energy, electrical energy, and light energy. Question number 23. Which law was verified experimentally by James Prescott Joule? Answer. Law of conservation of energy. Question number 24. Who discovered the value of the mechanical equivalent of heat? Answer. James Prescott Joule. Question number 25. What is the unit of energy and work? The unit of energy and work is called joule. Question number 26. Write a short note on kinetic energy. Answer. The energy possessed by an object due to its motion is called kinetic energy. Its unit is joule. Kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity. The kinetic energy of an object increases with its speed. The kinetic energy possessed by an object of mass m moving with a uniform velocity v is given by ke equals half mv squared. Question number 27. Derive the equation for kinetic energy. Answer. Consider an object of mass m moving with a uniform velocity u. A force F is applied on it which displaces it through a distance s and it attains a velocity v. Then work is done to increase its velocity from u to v. W equals F into s. According to the equation of motion, v squared minus u squared equals 2as. Therefore, s equals v squared minus u squared by 2a, where a is uniform acceleration, u is initial velocity, and v is final velocity. Also from F equals ma. Substituting the values of F and S in W equals Fs, we have W equals ma into v squared minus u squared by 2a, or W equals half m into v squared minus u squared. If initial velocity u equals 0, then W equals half mv squared. This work done is equal to the kinetic energy of the object. Therefore, kinetic energy equals half mv squared. Question number 28. What will cause greater change in kinetic energy of a body? Changing its mass or changing its velocity? Answer. Changing in velocity will cause greater change in kinetic energy. Question number 29. A bullet of mass 8 gram is fired with a velocity of 80 meter per second. Calculate its kinetic energy. Answer: mass m equals 8 gram equals 8 by 1000 kilogram. Velocity v equals 80 meter per second. Kinetic energy Ke equals half mv squared equals half into 8 by 1000 into 80 the whole squared equals 25.6 joule. Question number 30. What is the work to be done to increase the velocity of a van from 10 meter per second to 20 meter per second if the mass of the car is 2000 kilogram? Answer: mass m equals 2000 kilogram. Initial velocity u equals 10 meter per second. Final velocity v equals 20 meter per second. Initial kinetic energy of the van equals half mu squared equals half into 2000 into 10 squared equals 1 lakh joule. Final kinetic energy of the van equals half mv squared equals half into 2000 into 20 squared equals 4 lakh joule. The work done equals change in kinetic energy equals 4000 minus 4 lakh minus 1 lakh equals 3 lakh joule. Hence, the kinetic energy of van increases by 3 lakh joule when it speeds up from 10 meter per second to 20 meter per second. Question number 31. Define potential energy with example. What is its unit? Answer: potential energy is defined as the energy possessed by an object by virtue of its position or configuration. Example: stretched rubber band. Its unit is joule. Question number 32. When an arrow is shot from its bow, it has kinetic energy. From where does it get the kinetic energy? Answer: a stretched bow possesses potential energy due to the change in its shape. To shoot the arrow, the bow has to be released. So, its potential energy is converted into kinetic energy of the arrow. Question number 33. Define gravitational potential energy. Answer: the gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to that point against gravity. Question number 34. Derive the equation for potential energy. Answer: let the work done on the object against gravity equals W. Work done W equals force into displacement. Force F equals mass m into gravity G. Work done W equals mg into h equals mgh. Since work done on the object is equal to mgh and energy equal to mgh units is gained by the object. This is the potential energy of the object. So, potential energy EP equals mgh. Question number 35. A body of mass m is raised to a vertical height h through two different paths A and B. What will be the potential energy of the body in two cases? Give reason. Answer. The work done against gravity in both the cases is mgh. It is independent of the path along which the body is moved and depends only on the initial and final positions of the body. Question number 36. A boy weighing 40 kg climbs up a vertical height of 200 meter. Calculate the amount of work done by him. How much potential energy does he gain? G equals 9.8 meter per second squared. Answer. Mass m equals 40 kg. Acceleration due to gravity G equals 9.8 meter per second squared. Height h equals 200 meter. Work done by the boy equals mgh equals 40 into 9.8 into 200 equals 78,400 joule. Gain in potential energy equals work done equals 78,400 joule. Question number 37. An object of mass 20 kg is at a certain height above the ground. If the potential energy of the object is 39,600 joule, find the height at which the object is with respect to the ground. Given G equals 10 meter per second squared. Answer. Mass m equals 20 kg. Acceleration due to gravity G equals 10 meter per second squared. Potential energy EP equals m into G into h. 39,600 joule equals 20 into 10 into h. So h equals 39,600 divided by 20 into 10 equals 198 meter. Hence, the object is at a height of 198 meter. Question number 38. What kind of energy transformation takes place when a body is dropped from a certain height? Answer. When a body falls, its potential energy gradually gets converted into kinetic energy. On reaching the ground, the whole of the potential energy of the body gets converted into kinetic energy. Question number 39. State the law of conservation of energy. Answer. The law of conservation of energy states that energy can only be converted from one form to another. It can neither be created nor destroyed. Question number 40. What do you mean by transformation of energy? Answer. The change of energy from one form of energy into another form of energy is called transformation of energy. Question number 41. What is meant by total mechanical energy of an object? Answer. The sum of kinetic energy and potential energy of an object is its total mechanical energy. Question number 42. The potential energy of a freely falling object decreases progressively. What happens to its 1. Kinetic energy, 2. Total mechanical energy? State the law on which your answer is based. Answer. 1. As potential energy decreases with the decreasing height, the speed of the object will increase and hence its kinetic energy will increase. 2. Total mechanical energy will remain constant. It is based on the law of conservation of energy, which states that energy can neither be created nor be destroyed. It can only be transformed from one form to another. Question number 43. An object of mass 10 kg is dropped from a height of 5 meter. Calculate 1. Kinetic energy, 2. Potential energy, 3. Total energy. Take the value of G as 10 meter per second squared. Answer 1. Mass m equals 10 kg, height h equals 5 meter, acceleration due to gravity g equals 10 meter per second squared, velocity v equals 0, kinetic energy half mv squared equals half into 10 into 0 equals 0, potential energy mgh equals 10 into 10 into 5 equals 500 joule, total energy equals potential energy plus kinetic energy at height 5 meter equals 500 joule. Question number 44. Define power. What is its SI unit? Answer. Power is defined as the rate of doing work or the rate of transfer of energy. The unit of power is watt. Power equals work by time. Question number 45. Define 1 watt of power. Answer. The power of an agent is said to be 1 watt if it does 1 joule of work in 1 second. Question number 46. Define average power. Average power is defined as the ratio of total work done by the total time taken. Average power equals total energy consumed divided by total time taken. Question number 47. What amount of energy in kilowatt hour is consumed in 10 hours by a machine of power 500 watt? Answer. Power P equals 500 watt, time T equals 10 hour, energy consumed equals power into time equals 500 into 10 equals 5000 watt hour equals 5 kilowatt hour. Question number 48. A girl of mass 40 kg climbs a rope 6 meter long at constant speed in 15 seconds. What power she expends during the climb? Value of G equals 9.8 meter per second squared. Answer. Mass m equals 40 kg, acceleration due to gravity G equals 9.8 meter per second squared, height h equals 6 meter, time taken t equals 5 seconds, power equals work done by time taken equals mgh by t equals 40 into 9.8 into 6 by 15 equals 156.8 watt. Question number 49. A boy of mass 55 kg runs up a staircase of 50 steps in 10 seconds. If the height of each step is 10 cm, find his power. Take G equals 10 meter per second squared. Answer. Mass m equals 55 kg, acceleration due to gravity G equals 10 meter per second squared, weight of the boy equals m into G equals 55 into 10, 550 Newton. Height of the staircase h equals 50 into 10 by 100 equals 5 meter. Time taken to climb t equals 10 seconds. Power P equals work done by time taken equals mgh by t equals 55 into 10 into 10 divided by 10 equals 275 watt. Hence, power is 275 watt. Question number 50. What is the commercial unit of electric energy? Answer. The commercial unit of electric energy is kilowatt hour, kWh. Question number 51. Why is it required to use kilowatt hour as commercial unit of electrical energy? Answer. The unit joule is too small and hence it is inconvenient to express large quantities of energy, so we use a bigger unit of energy called kilowatt hour. Question number 52. How do you differentiate kilowatt from kilowatt hour? Answer. Kilowatt is the unit of power, while kilowatt hour is bigger unit of energy. Question number 53. Write commercial unit and SI unit of energy. Answer. Commercial unit of electrical energy is called kilowatt hour and the SI unit is joule. State the relation between kilowatt hour and joule. Answer. Kilowatt hour equals 1 kilowatt into 1 hour equals 1000 watt into 3600 second equals 3.6 into 10 raised to 6 joule. So 1 kilowatt hour equals 3.6 into 10 raised to 6 joule. Question number 55. A television of 120 watt is used for 6 hours per day. Calculate the units of energy consumed in 1 day by the television. Answer. Power of television equals 120 watt equals 0.12 kilowatt. Time used T equals 6 hours. Energy equals power into time taken equals 0.12 kilowatt into 6 hours equals 0.72 kilowatt hour equals 0.72 units. The energy consumed by the television is 0.72 units.